The size of earthen bricks varies based on user needs, with no strict dimensional regulations. To make these bricks, yellow soil, red clay, and black soil or other sticky soils are mixed with water to form a thick slurry. Chopped rice straw or rice husks are added to enhance strength and prevent cracking. Traditionally, oxen were used to stomp the mixture for even consistency, but today, this is done manually by foot or with mechanical aids like iron oxen. Once thoroughly mixed, the mud is poured into molds, beginning with a layer of rice husks to prevent sticking. The mud straw mixture is then added and compacted. After partial drying, the molds are removed, and the bricks are sun-dried, turned regularly to ensure uniform drying. This natural drying process, which can take several weeks, produces strong, durable bricks ideal for construction. The result is an eco-friendly, sturdy material well-suited for traditional earthen houses. Once the earthen bricks are ready, site preparation begins by marking the layout to ensure accurate positioning. A trench, about 1 foot deep and 1 foot wide, is excavated around the site to form the foundation. Cobblestones, typically 10 to 40 centimeters in diameter and sourced from the site, are stacked in layers, with gaps filled using red soil for stability. Cement mortar, mixed in a 1:3 ratio of cement to sand, is used as a bonding agent. It must be applied within an hour to prevent hardening. Before building the walls, horizontal guidelines are marked to ensure precise placement. Each layer of bricks is checked for levelness with a spirit level, while a plumb line ensures vertical alignment. This meticulous process prevents structural weaknesses and maintains the integrity of the walls. During bricklaying, a machete is used to trim excess material from the brick surfaces, ensuring strong adhesion between layers. At corners, bricks are arranged in an interlocking pattern, which enhances stability and prevents shifting over time. Spaces are left open for doors and windows, with the door frame constructed using stacked red bricks. Window lintels made from durable ironwood are carefully fitted into pre-reserved openings for structural reinforcement. The width of the walls must match the foundation exactly to maintain even weight distribution. The bonding material, known as mortar, consists of soil, rice husks, and chopped straw. This mixture provides both flexibility and durability. The base plaster layer, essential for binding the wall together, is mixed in a 2:8 ratio of lime to soil, with 5% rice husks and straw. It is applied no thicker than 2.5 centimeters and must dry fully before adding the final plaster coating. To ensure stability, construction involves carefully pressing, squeezing, and pushing each brick into place, maximizing contact between layers. This method prevents air gaps and reinforces the overall strength of the structure. Through these techniques, earthen walls become highly durable, capable of withstanding environmental elements while maintaining breathability, insulation, and sustainability. In traditional Taiwanese rural areas, earthen houses were constructed using locally sourced materials, making them environmentally friendly and sustainable. These buildings produce minimal waste during both construction and demolition, offering a natural alternative to modern materials. The framework is assembled using a lashing technique rather than nails, which allows for slight flexibility, reducing the risk of structural damage over time. The construction begins with the main beam, which is first shaved flat on top to create a stable surface for supporting the roof structure. This beam is then positioned and fixed in place using wooden pegs. The height and placement of the beams are precisely marked before installation, ensuring proper alignment with the rest of the structure. Any protruding bricks that interfere with the frame's positioning are trimmed accordingly. Once the main beam is secured, secondary beams or cross beams are added. These beams distribute the weight of the roof evenly. To prevent them from shifting during installation, a small brick is placed underneath each beam before nailing it into place. After securing all beams, rafters are installed to provide additional support for the roof covering. Before attaching them, each rafter is carefully measured, marked, and notched at the ends to ensure a snug fit against the main beam. Using a pneumatic nail gun, the rafters are firmly fastened in their designated positions. Installing the thatch roof covering the final step is covering the roof with layers of thatch, which provides excellent insulation and water resistance. Thatch bundles, each approximately 80 centimeters long and 1 centimeter thick, are carefully arranged starting from the eaves. The cut ends of the thatch face downward to ensure efficient water runoff and protection against rain infiltration. To secure the thatch, bamboo strips are placed over each layer and fastened using an 8-knot lashing technique with flexible bamboo fibers. This traditional method ensures a tight hold, preventing the thatch from shifting or becoming loose over time. To further reinforce the roof, additional wire bindings are applied, increasing resistance to strong winds and harsh weather conditions. By following this methodical construction process, the roof becomes highly durable while maintaining the traditional aesthetic and sustainability of an earthen house. The completed structure provides excellent ventilation, keeping the interior cool in summer and warm in winter, while also offering long-term resilience against natural. To enhance the durability of the walls and ensure a comfortable indoor environment, a layer of lime plaster is applied to the interior surfaces. This plastering process serves multiple functions. It prevents rainwater infiltration, keeps insects out, protects the structure from erosion, enhances moisture resistance, and improves thermal insulation. Additionally, the lime plaster gives the walls a smooth and aesthetically pleasing finish, improving the overall living quality of the house. Before applying the plaster, the walls are cleaned of any loose debris. The plaster mixture consists of lime, clay, and finely chopped straw or rice husks, which help increase the bonding strength and flexibility of the plaster. The ratio of lime to clay is typically 2:8, with about 5% straw or rice husks added to reinforce the mixture. The plaster is applied in thin layers, each not exceeding 2.5 centimeters in thickness. A traditional pressure squeezing and pushing technique is used to ensure the plaster adheres well to the earthen walls. The base coat is left to partially dry before any additional layers are applied. Smoke fumigation for pest control. Once the plastering process is completed, an important fumigation step follows. Dried branches and twigs are burned inside the house, producing smoke that fills the interior. This process has several benefits: deters pests. The smoke drives away insects, termites, and other unwanted pests that might otherwise infest the earthen structure. Installation of windows. Earthen houses typically feature a 2-layer window system for better insulation and ventilation control. The outer layer is fixed and non-movable, while the inner layer consists of sliding or hinged panels that can be opened and closed as needed. Before installation, the window frames are test-fitted into their designated openings. If any portion of the earthen bricks obstructs the proper placement of the frame, it is carefully chipped away to create a precise fit. The edges of the frames are then trimmed and adjusted to ensure a tight seal. To secure the windows in place, red clay is applied to fill any remaining gaps between the frame and the surrounding wall. This prevents drafts, enhances insulation, and improves the overall stability of the window installation. Installation of doors. The doors are the final major component to be installed. Each door consists of several key elements, including the door panels, upper and lower door frames, hinges, and locking mechanisms. The installation process follows these steps. Adjusting the door frames. The upper and lower door frames are first positioned and aligned with the walls. They are nailed securely into place to prevent shifting. Sizing and mounting the door panels. The door panels are cut to match the exact dimensions of the opening. They are then mounted onto the door frames, ensuring a snug and balanced fit. Fitting the hinges and latches. The appropriate hardware, including hinges, door latches, and locks, is installed to allow smooth operation. Sealing the gaps. Any minor gaps between the door frame and the surrounding wall are filled with red clay to enhance the seal and improve insulation. Once the doors are in place and function correctly, the final inspection is conducted to check for any necessary adjustments.
Bamboo, a highly sustainable resource, is harvested when mature, typically after 3 to 5 years. It is chosen for its remarkable durability and natural resistance to water. Post-harvest, the bamboo is cut into smaller, manageable pieces and boiled in water. These pieces are carefully measured and cut to specific lengths required for various applications. The boiled bamboo pieces are dried thoroughly, often in kilns, to ensure they are moisture-free. The bamboo is cut into the desired size and shape for toothbrush handles. This process involves precision to ensure uniformity and comfort in the final product. Each bamboo piece is shaped into a toothbrush handle using specialized machinery that precisely carves and molds the bamboo, ensuring consistent size, ergonomic design, and smooth contours for comfortable use. The handles are sanded to create a smooth surface, ensuring they are comfortable to hold and use. Multiple rounds of sanding are typically employed, progressing from coarse to fine grit. The bristle embedding process involves drilling small holes into the toothbrush head. Bristles, often made from biodegradable materials like nylon 4 or plant-based fibers, are then inserted into these holes. The bristles are secured either by using an adhesive or by anchoring with small metal staples. The toothbrush handles may be treated with natural oils or varnishes to enhance water resistance and longevity. This also provides a pleasant finish and ensures the toothbrush remains hygienic. The production of bamboo storage baskets begins with the careful selection of raw materials. Natural bamboo strips, renowned for their durability, flexibility, and eco-friendliness. Bamboo is chosen not only for its sustainable growth, but also for its strength and resilience, which are essential qualities for storage baskets that need to be both sturdy and lightweight. Once harvested, the bamboo is cut into strips of varying lengths and widths, which will be refined further during the production process. In this phase, the bamboo strips undergo a rigorous preliminary screening process. Each strip is examined for quality, ensuring that only those without significant defects, such as cracks, discolorations, or insect damage, are selected. After screening, the high-quality bamboo strips are sent to the processing workshop. Here, the strips are first fed into a machine that standardizes their width. This step is crucial as uniform width ensures consistency in the final product. To guarantee precision, samples of the strips are re-inspected to verify the correct dimensions. Following this, the strips undergo another round of screening to identify any minor defects that may have been missed initially. In the finishing workshop, the bundled bamboo strips are first cut to a uniform length. Precision is key in this step to ensure that all strips are of identical length, which is crucial for the symmetry and stability of the final product. Specialized cutting machines are used to achieve this accuracy. After cutting, each strip is inspected to confirm it meets the length requirements, ensuring consistency across all pieces. Next, the uniformly cut bamboo strips are fed into a shaping machine. This machine molds the strips into the desired shape, typically forming the frame of the basket. The shaping process involves bending and securing the bamboo in a specific form to create a sturdy and aesthetically pleasing frame. The precision of this machine ensures that each frame is identical, facilitating easier assembly and ensuring uniformity in the final products. After shaping, the bamboo frames often become entangled or stuck together. Skilled workers manually separate these frames, ensuring they are not damaged during the process. Surface preparation involves multiple steps to ensure the bamboo frames are smooth and ready for assembly. Initially, the frames are sanded to remove any rough edges or splinters, creating a smooth surface. Drilling and slotting are critical steps in preparing the bamboo frames for assembly. Each bamboo frame is carefully positioned in a drilling machine where precise holes are drilled at designated points. These holes are essential for fitting the different parts of the basket together during the final assembly stage. Despite careful processing, some bamboo frames may exhibit minor defects after drilling and slotting, small cracks, uneven edges, or splinters. Inspect each frame, identifying these imperfections. Using fine tools and repair techniques, they address these defects to restore the frames to their optimal condition. After the bamboo frames undergo drilling, slotting, and initial sanding, they are placed in a staggered position to dry. This step is crucial to ensure that any residual moisture from the processing stages evaporates completely, which helps prevent warping or deformation of the frames. The frames are arranged with adequate spacing between them to allow for proper air circulation, which facilitates even and thorough drying. This further sanding addresses any imperfections that may have emerged during the drying process, rough spots, or minor irregularities. Specialized sanding tools are used to smooth the surface, paying particular attention to areas like the inner circles and edges, which require extra care. This step ensures that the bamboo frames are perfectly smooth and ready for the final finishing touches. The bamboo frames are prepared for painting by first ensuring they are clean and dry. Paint is applied in multiple coats, usually sprayed back and forth twice, to achieve a smooth and even finish. This process enhances the frame's appearance and adds a protective layer, ensuring durability and a polished look.
The first step in the manufacturing process is the selection of the appropriate raw materials. Birchwood is often chosen to make disposable spoons. The wood is carefully selected to ensure it is free from defects and suitable for processing. Once the raw wood is obtained, it is prepared for further processing. A cutter is used to cut the wood into smaller, manageable pieces. The cut wood pieces are then subjected to a machine that removes the outer shell or bark from the surface. This process is called peeling and is done to expose the smoother and more uniform wood underneath. After peeling, the wood is processed into rolls. This involves shaping the wood into cylindrical forms, which will later be used to create the spoon handles. The processing may be done using specialized machinery that can handle large volumes of wood efficiently. Once the wood is formed into rolls, it is subjected to a pressing process to enhance its strength and durability. This step involves placing the rolls under high pressure, which compresses the wood fibers tightly together. The pressure applied helps to achieve a compact and sturdy structure, ensuring that the spoon handles can withstand the rigors of regular usage without breaking or splintering. By undergoing the pressing process, the wooden spoon handles become robust and reliable, providing a dependable utensil for consumers. This step is crucial in guaranteeing that the wooden disposable spoons maintain their structural integrity throughout their lifespan. Following the pressing stage, the wooden spoon handles need to be thoroughly dried. A dryer is used to remove excess moisture from the wood, ensuring that the spoons are sturdy and resistant to warping or cracking. Proper drying also helps in preventing the growth of mold or other contaminants. The final step in the manufacturing process involves grinding the wooden spoon handles. This is typically done using a continuous grinding method, which smooths the edges and surfaces of the spoons. The grinding process ensures that the spoons have comfortable and smooth edges, making them convenient to use without the risk of splinters. After the grinding process, the wooden disposable spoons undergo a meticulous quality control inspection. Skilled workers carefully examine each spoon for any defects or imperfections, ensuring that only the highest quality spoons are selected for packaging. Once approved, the spoons are carefully packaged for distribution, typically in packs or boxes that are designed to protect them during transportation. The manufacturing process of wooden disposable spoons emphasizes both functionality and aesthetics. The smooth edges achieved through the grinding process make the spoons comfortable to use. Additionally, the natural grain and texture of the wood contributes to their visual appeal. Furthermore, by utilizing sustainable materials like wood, these disposable spoons provide an environmentally friendly alternative to plastic cutlery. Wood is a renewable resource, and using it for disposable utensils helps reduce reliance on non-biodegradable materials. This promotes a more eco-conscious approach to food service and contributes to the reduction of plastic waste in landfills and oceans. The bamboo salt manufacturing process is a unique and intricate method that involves several steps to create a special type of salt infused with the essence of bamboo. To begin the manufacturing process, bamboo stalks that are more than 3 years old are carefully selected. These bamboo stalks contain a rich array of minerals, including potassium and calcium. The bamboo stalks are then cut open on one side, leaving the other side closed to contain the salt. Pine wood, the second raw material, is used to create a fire. The pine trees are split into several parts and naturally dried in a rain-free environment to preserve the pine resin within the wood. Sea salt, harvested from the west coast of Korea, is the third ingredient. The sea salt undergoes meticulous management with an origin tracing system. Before being placed inside the bamboo stalks, the sea salt is finely ground. It is crucial to firmly pack the sea salt into the bamboo stalks so that it can harden and be effectively roasted. The essence of the bamboo is better absorbed into the salt when it is tightly packed. Clay, which also contains minerals, is used to seal the filled bamboo stalks. The filled bamboo stalks are then arranged neatly in an iron kiln. A fire is ignited using the well-dried pine wood. The high temperature of the pine wood fire melts impurities in the sea salt and allows the minerals from the bamboo and red clay to permeate the salt pillars. During the burning process at a temperature of 800 degrees Celsius, the bamboo stalks are turned into ash while the salt pillars and clay remain. The hardened clay is removed, and the bamboo ash is brushed off the salt pillars. Some bamboo charcoal may be present in the salt, which is safe to consume and adds to the unique characteristics of bamboo salt. The salt pillars are then placed into a grind, resulting in one-time roasted bamboo salt powder. This powder is put back into new bamboo stalks and firmly packed using a vibrating tool. The bamboo stalks are covered with clay and returned to the iron kiln. Another fire is lit using pine wood. This process of filling, packing, and burning the salt pillars is repeated 8 times in total over a period of 2 weeks. Careful attention is given to every step of the process. The salt pillars are crushed after each burning and put back into new bamboo stalks. After the 8th time, the bamboo salt is placed in a specially designed iron kiln for the 9th and final melting process. The skilled craftsman creates a resin fire with a temperature exceeding 1,500 degrees Celsius. This high heat melts the 8th time roasted salt pillars and the molten salt flow. After 15 days of sincere effort and hard work, the molten bamboo salt solidifies and cools down for 2 days. The completed bamboo salt is then removed by turning the stalks upside down. This moment is filled with excitement and anticipation, as the culmination of the 15-day process is finally revealed. Experienced individuals carefully separate the completed 9-time roasted bamboo salt into parts mixed with bamboo charcoal and parts without. This separation is essential to ensure the proper quality of the bamboo salt. The resulting 9-time roasted bamboo salt shines like crystals and is a testament to the meticulous manufacturing process. It is a treasure, highly regarded as a diamond-like gem. The bamboo salt is exported worldwide, showcasing its exceptional quality to the world. The bamboo salt crystals are crushed using a crusher to increase production. The crushed bamboo salt powders and grains are mixed together. The mixed powders and grains can be used in various ways. The process begins with the extraction of guadua canes. Guadua is known for its rapid growth and abundant availability, making it an ideal resource for sustainable manufacturing. However, guadua is not homogeneous and requires significant manual labor for its transformation. Villegas recognizes this challenge and seeks to find a way to utilize guadua effectively and turn it into a valuable product that can replace wood. To transform guadua into boards, Villegas and his team have developed specialized machinery tailored for this specific process. By investing in innovative technology, they can optimize the utilization of guadua and achieve consistent results. The ultimate goal is to produce boards of commercial dimensions, allowing for large-scale production and widespread adoption of ecoboards. An essential aspect of the manufacturing process is the establishment of partnerships with guadua producers. Rather than relying solely on purchasing raw materials, Villegas aims to collaborate closely with guadua farmers. By forming a network of producers cultivating guadua on approximately 300 hectares of land, they ensure a continuous and sustainable supply of raw material. This approach promotes a self-contained production cycle that reduces the environmental impact and supports local communities. Preservation is a crucial step in the manufacturing process of ecoboards. Villegas emphasizes that no chemicals or toxins are used in this process. Instead, a physical-chemical method is employed to extract the sugar from the guadua cane while fixing the remaining crystals to prevent fermentation. This preservation technique is eco-friendly and ensures that the final product is safe and free from harmful substances. The adhesive used in the manufacturing process is also carefully selected to align with the ecological principles of ecoboards. The adhesives are completely non-toxic and compatible with food products. They are resistant to moisture, ensuring the durability and longevity of the boards. By using eco-friendly adhesives, the manufacturing process minimizes harm to the environment and ensures the safety of the end users. Energy generation in the manufacturing process is another aspect where sustainability is prioritized. The process relies on combustion and cyclone filtration to generate the necessary heat and remove any particles or impurities. The energy required for drying and other manufacturing stages is generated from the combustion process, making it self-sustaining and reducing reliance on external energy sources. The first step in the manufacturing process is the selection of mature bamboo stems. Only bamboo stems between 4 and 6 years old are chosen for harvest. These stems, known as guadua combs, are extremely strong and hardened, maximizing their mechanical properties for construction applications. Young guadua bamboo can be identified by its bright green color and white nodal rings, as depicted in the provided picture. When the bamboo stem changes to a grayish-green color and the white bands at each node nearly disappear, it indicates the bamboo's maturity, and it can be harvested from the plantation. During harvesting, the remaining stumps are cut just above the first or second node above ground level. This method prevents rainwater from collecting in the column, which could attract insects and lead to rot, weakening the bamboo root system and the entire clump. Guadua bamboo can grow taller than 25 meters 82 feet, so the stems are cut to size inside the plantation. Freshly cut guadua poles, measuring 6 meters 20 feet in length, can weigh over 70 kilograms, 155 pounds. After harvesting, the bamboo poles are transported to the treatment facility. Before the treatment process, the poles are cut to the required size. All bamboo poles need to be perforated on the inside, because the natural water-repellent outer layer of bamboo makes it impossible for preservatives to enter from the outside. A long steel rod is used to penetrate each node along the length of the bamboo pole. Next, the poles go through the preservation process. Before treatment, all moss and surface stains are cleaned off using a high-pressure washer. Additionally, each node is individually cleaned by hand with the steel brush. The preservation of bamboo is crucial for its durability, and guava bamboo uses a non-toxic borax and boric acid solution that is colorless and dissolves in hot water. The solution is introduced from the inside of the bamboo, allowing the fibers to absorb it. Sinker loads are used to keep the bamboo poles 100% submerged in the solution. The poles remain in the treatment tank for at least 5 days to ensure full absorption of the chemicals. After the preservation treatment, the bamboo poles are sun-bleached in open air for approximately 1 to 2 weeks. They are rotated daily to avoid cracking. Sun-bleaching removes most of the chlorophyll from the outer layer of the bamboo, resulting in a uniform beige color, which is desirable as a construction material. This process also prepares the poles for staining or painting if required. To facilitate inventory management, all guava bamboo poles are color-coded by diameter class. Once color-coded, the poles are ready for shipping and comply with the company's quality standards, including limited cracks and bends, moisture content, maturity, and color. When embarking on the task of assembling a log cabin kit for the roof, using rounded logs, there are several important steps to follow. Firstly, it is crucial to ensure that you have a suitable workspace and the necessary tools at your disposal. To begin, carefully choose the location where the log cabin will be assembled. A flat and level surface is ideal to ensure stability and ease of construction. Once the workspace is ready, it is time to start working with the rounded logs. The rounded logs used in the construction of log cabins undergo a special treatment to achieve precise dimensions and a smooth surface. This treatment involves removing the bark and using a cutter to shape the logs into uniform sizes. Precise measurements are essential during this step to ensure that each log fits together seamlessly. When it comes to assembling a log cabin kit for the roof using rounded logs, the use of a drill is an important tool in the construction process. With precise measurements and the appropriate drill bits, the drill enables you to create holes and secure the logs together. The size of the drill bit should match the diameter of the screws or fasteners you will be using. Using the wrong size bit can result in loose connections or damaged wood. Using a cutter, the logs are cut according to precise measurements. This step ensures that the logs fit together snugly and securely, creating a structurally sound roof for the cabin. It is crucial to take precise measurements and make accurate cuts to maintain the integrity of the construction. With the rounded logs now prepared and treated, the assembly process can commence. Begin by laying out the logs according to the predetermined design and sequence. The notches or grooves on each log are carefully aligned, allowing them to interlock securely. This interlocking mechanism is what gives log cabins their structural strength. As you progress with the assembly, pay close attention to the fit and alignment of each log. Adjustments may be necessary to ensure a tight and secure fit. It is also crucial to periodically check the levelness and plumpness of the structure to maintain its stability and integrity. The roof installation process is a crucial step in assembling a log cabin kit, as it provides protection from the elements and completes the structure. The first step is to assemble and secure the roof structure, including rafters and purlins, to the log walls. This framework provides support for the roofing material and ensures the stability of the roof. Once the roof structure is in place, a layer of roofing felt or underlayment is applied. This acts as a moisture barrier, preventing water from seeping into the roof and causing damage. The underlayment is rolled out and secured, overlapping each row to ensure complete coverage. Next, drip edges are installed along the eaves and rakes of the roof. These metal strips help direct water away from the roof and prevent it from seeping into the underlying materials. Drip edges are nailed or screwed into place, ensuring a secure attachment. The chosen roofing material, such as shingles, metal sheets, or tiles, is then installed. Starting from the bottom edge of the roof, each piece is laid and fastened according to the manufacturer's instructions. The roofing material is carefully aligned and overlapped to create a watertight barrier.